very good afternoon to you all. Yes, a very good afternoon. So basically, today we are going to start with the new chapter. Rather, we are going to continue with a same chapter, which was of chapter number 7, lenses. Last lecture, mein, we have completed a majority of the part, and in this lecture, we are going to carry on the further part of it. Okay, Chalo, let's start. We will continue now.
Lens
For the
formula.
continuation is that we will continue from lens formula. प्रीवियस लेक्चर में दो टाइप के जो लाइक लेंसेस हमारे पास है, तो उस लेंसेस के अकॉर्डिंग कैसे इमेजेस फॉर्म होते हैं, वेयर द ऑब्जेक्ट इज केप्ट. अगर ऑब्जेक्ट कहीं पे रखा है तो उसका इमेज कहाँ बनेगा, रियल है, इन्वर्टेड है, सब कुछ वी हैव स्टडीड. नाउ वी आर गोइंग टू अंडरस्टैंड अबाउट द लेंस फॉर्मूला. ओके, एवरीबडी पे अटेंशन.
The formula showing the relation between distances of the object U, the distance of the image B, and the focal length F is called the lens formula.
Yes.
It is
So
given below.
basically you have to work. हमको ये तीन चीजों पे we have to find. The first is the distance of the object. तो जहाँ पे object रखा है उसके बीच का जो distance है, it is noted as U. उसको U बोला गया है, U. Distance of the image, जहाँ पे image form हुआ ये इसका, लाइक द कॉन्वेक्स लेंस के लिए इमेज यहाँ फॉर्म हुआ है, कॉन्केव के लिए इमेज यहाँ फॉर्म हुआ है. तो डिस्टेंस ऑफ द इमेज, जो इमेज का डिस्टेंस है वो v, एंड द फोकल लेंथ, और जो फोकल लेंथ होगा दैट इज f. ओके, सो बाय यूजिंग these three things like u, v and f, you should know what is u, you should know what is v, you should know what is f. ठीक है, तो ये तीनों को यूज करके यू कैन फाइंड द फॉर्मूला फॉर द लेंस, दैट इज द लेंस फॉर्मूला. 1 by v minus 1 by u is equal to 1 upon f. Okay, let's understand this thing again.
1 upon V minus 1 upon U is equal to 1 upon F. The lens formula is same for any spherical lens and any distance of the object from the lens.
Yes, so you don't have two different lens formula for the different lenses कि कॉन्वेक्स के लिए दूसरा लेंस हुआ और कॉन्केव के लिए दूसरा फॉर्मूला हुआ. नो, इट इज नॉट लाइक दैट. लेंस फॉर्मूला इज सेम फॉर बोथ द लेंसेज. कॉन्वेक्स के लिए भी वही है और कॉन्केव के लिए भी सेम इट इज. ओके, अंडरस्टूड. सो द लेंस फॉर्मूला इज सेम फॉर बोथ द लेंसेज. ये दोनों भी लेंसेज के लिए लेंस फॉर्मूला इज द सेम. 1 upon v minus 1 upon u equals to 1 upon f. Fine, where f is the focal length, u is the distance between the object, and this is the distance in the image. Okay, now let's understand the next one.
Magnification M. The magnification due to a lens is the ratio of the height of the image h2 to the height of the object h1.
Yes. So magnification
is equal to height of the object divided by height of the image. That is, m is equal to h2 upon h1.
Yes, so it is written as कि when you have to find the magnification. Okay, so when you want to find the magnification of a lens, so उस time पे you have to find it in the ratio format. Ratio like numerator में कुछ होगा, denominator में कुछ होगा. So see here, the magnification due to lens, because of the lens, the concave हो या convex हो, both the lenses, it is the ratio. Ratio means upon के form में height of the object, जो आपने object पहले place किया, अगर object है then only you will get an image. Okay, so height of the object divided by height of the image. So it is h2 upon h1. The magnification due to lens is the ratio. See ratio, can you see the ratio? Yes, ratio of the height of the object to the height of the image. Okay, so height of the image h2 to h1. Clear to everyone? Okay, now let's move on to the next one.
This is equation 1. The magnification due to a lens is also related to the distance of the object U and that of the image V from the lens. Magnification is equal to distance of the image divided by distance of the object.
Okay, so if you want to find a magnification, मैं आपको height mention नहीं किया है, तो no worry, you can calculate the magnification also with the help of the value of u and value of v. Now we all know what is the value of u, the distance between the object या फिर the distance of the object, and what is the distance of the image. तो ये अगर आपके पास if you have the value of u and if you have the value of v, then also you are able to find the magnification with the help of u and v, which is nothing but distance of the object and distance of the image, distance formed by the object and the image. Okay, yes, now please pay attention. See, it is again the ratio.
M is equal to V upon U.
Yes, v is the image and u is the object. Okay, yes.
This is equation 2. Use your brain power. From equations 1 and 2, what is the relation between H1, H2, U and V? Answer: magnification is equal to height of image upon height of object, that is M is equal to H2 upon H1, equation 1. And magnification is equal to distance of image upon distance of object, that is M is equal to V by U, equation 2. From equation 1 and equation 2, we can
see both the equations we know. Magnification of the lens also we know, that is h2 upon h1, and magnification of the with the help of the u and v also we know, that is v divided by u. So now let's understand what is the difference between, or what is the relation between them. Okay,
take the relation between them as M is equal to H2 upon H1 is equal to V upon U. Take two convex lenses of different sizes. Collect sunlight on a paper using one of the lenses. The paper will start burning after a while. Note the time required for the paper to start burning. Repeat the process for the second lens. Is the time required the same in both cases? What can you tell from this? Answer: the time required to burn the paper in both the cases is not same. From this we can say that the lens that has larger capacity to converge the incident rays will burn the paper fast.
Yes, so the lens which has a larger capacity to converge the incident ray will burn the paper fast. So it has the capacity to burn the paper fast. Okay, now let's move on to the next one, that is the power of the lens.
The capacity of a lens to converge or diverge incident rays is called its power, P.
Yes.
The power of a lens depends on its focal length. Power is the inverse of its focal length. Diverge incident rays is called its power, P.
Yes. So the capacity of the lens, see, this lens is having a capacity to either converge it or either diverge it. Okay. So the power of the lens to converge the rays or to diverge the rays is called as the power of the lens. Okay, as we have studied कि अगर वो lens अगर थोड़ा कम होगा तो less light will converge or diverge. अगर वो lens थोड़ा ज़्यादा बड़ा होगा तो it has a large power to converge or diverge. So it totally depends upon the capacity of the lens. Now lens की कितनी capacity है, जितने भी incoming rays है उसको converge करने की कि diverge करने की, that is called as the power of the lens. Okay, now pay attention.
The power of a lens depends on its focal length. Power is the inverse of its focal length, F. F is expressed in meters. The unit of the power of a lens is diopter or D.
Yes, now this point is extremely important to understand. The power of the lens depends on its focal length. Now we all know what is focal length. So see, this capacity or the power of the lens, it is depending upon the focal length F. Now power is the inverse of its focal length. So if I want to calculate the power and if I have the F, so just the inverse of the power is called as focal length is called as a power, and F is expressed in meters, like how many meter it is long, how many meters of the focal length and everything. The unit of the power of the lens is diopter, so it is represented using D, that is the diopter. Yes, exactly, Satish. That in the yes, they used to have the big enemies to destroy it, like using the magnifying one, right?
P is equal to 1 by f meter. 1 diopter is equal to 1 by 1 meter.
Yes. So as we said, the power of the lens is the inverse of focal length. Can you see this? The inverse of the focal length. So as we see the inverse of the focal length, the focal length f is in the denominator. Okay. So it is the inverse of the focal length. So 1d equals to 1 upon 1m. Now next one.
Combination of lenses. If two
Now this is a
lenses with
different part.
focal
Please
length
understand.
f1 and f2 are kept in contact with each other, the combination has an effective focal length given by 1 by f is equal to 1 by f1 plus 1 by f2.
Correct. So
If the
if
power
I have combination of two lenses, see if I have two lenses. Now initially जब मैं आपको बोल रही हूँ find the focal length of one thing, you know how to find the focal length, right? तो आप calculate कर लोगे. But if I'm asking you to find the total focal length, both the lenses का, so at that time you have to first calculate the f1, you will calculate f2, and then you will merge this two. That means you will add this two. Okay. अगर आपको ऑलरेडी f1 और f2 दिया then not an issue, you have to just add it, but if not you will calculate it, and for the calculation we already know all the formulas. Okay, now let's talk about the power of the two lenses. Let's see.
The two lenses are P1 and P2, then the effective power of their combination is P is equal to P1 plus P2.
Yes, so if the power of the two lenses are P1, now let's see, as I have said, if focal length of the first lens is f1, the focal length of the second lens is f2. दोनों को ff रखोगे तो you will get confused. So we are notating it with f1 and f2. हम उनको एक name दे देते हैं f1 and f2. Similarly, for the power also, for the first length we will say power of the first length is f1 and the power of the second length is f2. And if I want to calculate total power, the combination of this we will say power equals to P1 plus P2. Understood? Yes. So basically nothing to worry about. Just as कि focal length जो भी focal length होगा, if you want the merge of it, combination of it, so it is f1 plus f2, and if you want the power of both lengths, it is p1 plus p2. Okay, please understand this
Thus,
thing.
when two lenses are kept touching each other, the power of the combined lens is equal to the sum of their individual parts. Solve example.
Yes. Now let's understand a solved example. Now we have studied about, see what we have studied is all the formulas, that is the lens formula, magnification, power of the lens, and also combination of the lenses. Now depending upon these formulas, we are going to calculate, or we are going to do the sum part. Okay. So now I want all my kids to answer it correctly. Okay. Chalo, let's understand the sum first.
1. An object is placed vertically
Please pay
at a
attention.
distance of 20 centimeters from a convex lens. If the height of the object is 5 centimeters and the focal length of the lens is 10 centimeters,
See, yeah, everything is given properly, that the object is placed at a distance of 20. So see, we place the object towards the right, image is formed towards the right. Everything you have to do this properly. Every time the object place is always on the left side, sign conventions we have learned, right? Yes. So see, the object is placed at a distance of 20 centimeter from the convex lens towards the left. They have not mentioned that you have to keep it towards the left. It is understood because we know the sign conventions. Now, if the height of the object is 5 centimeter, अगर height है उसका 5 centimeter and उसका focal length जो है वो 10 centimeter. Now, what we have to calculate? Let's see.
be the position, size and nature of the image. How much bigger will the image be as compared to the object?
Yes. तो अगर object यहाँ पे है तो image कहाँ form होगा? First of all, image will be formed on the right hand side ideally, basically. So that it also depends upon the lenses also. So वो image जो form होगा वो exactly कहाँ form होगा? What would be the like same जितना object है उतना ही होगा या उससे bigger या उससे smaller होगा? That we have to calculate, and we also have to calculate the nature of the image. Now let's see how to do this. Yes, everyone pay attention.
Given height of the object h1 is equal to 5 centimeters. Focal length f is equal to 10 centimeters. distance of the object u is equal to minus 20 centimeters. What is image distance v? What is height of the image h2? What is magnification m? Using the formula 1 by v minus 1 by u is equal to 1 by f, or 1 by v is equal to 1 by u plus 1 by f. Substituting the values, 1 by v is equal to 1 by minus 20 plus 1 by 10. Further, 1 by v is equal to minus 1 plus 2 by 20. 1 by v is equal to 1 by 20, or v is equal to 20 centimeters. The positive sign of the image distance shows that image is formed at 20 centimeters on the other side of the lens.
Yes, so just by using all the formulas, we are getting all the answers correct, as we have to find the distance of the image. Now we know for distance of the image, we need V. So we have calculated using it. Now next one, finding out the magnification. So as for also magnification, it is H2 upon H1 is equals to V upon U. Okay? So now we know the value of U, we know the value of V, we know the value of H1. So accordingly, we can find the height. Okay? So let's understand.
M is equal to H2 by H1 is equal to V by U, or H2 is equal to V by U into H1 by substituting the value.
Now we know what is the value of H1. See, H1 हमको पता है. We have calculated just U, we know from the question itself. So just by rearranging the term, like I want H2, I want the value of H2. So what I will do, I will move this H1, which is a divide form on the right hand side, which will go it into the multiplication form. So just by putting all the values, I will get the exact value of H2.
Values. H2 is equal to 20 by minus 20 into 5. Further, H2 is equal to minus 1 into 5. H2 is equal to minus 5 centimeters. M is equal to V by U, which equals 20 by minus 20, which equals minus 1.
Okay.
The negative sign of the height of the image and the magnification shows that the image is inverted and real. It is below the principal axis and is of the same size as the object.
Yes, so this minus sign indicates, if you remember sign conventions, जो principal axis है उसके ऊपर होगा तो it is positive, उसके नीचे होता it is negative. तो as we are getting it the height in negative, that means object यहाँ पे है तो image क्या होगा नीचे form हो रहा है. So it is real and inverted. Okay, and also talking about the magnification. So it is below the principal axis and it is of the same size and same height. See, 5 centimeter, 5 centimeter. Just it is positive, that means it is above the principal axis, and it is negative, that means it is below the principal axis. Understood? Yes. Now let's understand this.
Observe and discuss. Study the model depicting the construction of human eye with the help of teachers. Human eye and working of its lens. There is a very thin transparent cover, that is membrane, on the human eye. This is called cornea. Light enters the eye through it.
Yes, understand these things properly.
Amount of incident light is refracted inside the eye at the outer surface of the cornea. There is a dark, fleshy screen behind the cornea. This is called the iris. The color of the iris is different for different people. There is a small hole of changing diameter at the center of the iris, which is called the pupil. The pupil controls the amount of light entering the eye. If the light falling on the eye is too bright, pupil contracts, while if the light is dim, it widens. On the surface of the iris, there is bulge of transparent layers. There is a double convex transparent crystalline lens just behind the pupil. The lens provides small adjustments of the focal length to focus the image. This lens creates real and inverted image of an object on the screen inside the eye. The screen is made of light-sensitive cells and is called the retina. These cells get excited when light falls on them and generate electric signals. These signals are conveyed to the brain through optic nerve. Later, the brain analyzes these signals and converts them in such a way that we perceive the objects as they actually are. Isn't this amazing?
Yes. So basically, this is how the actually human eye work. Fine. So the whole eye it consists upon a different thing, pupil, lenses, and everything. So behind this we have a lens. The lens is there to focus the things. If the thing is at a very far distance, अगर बहुत दूर है, तो उसके according adjustment, and they make sure that the whole जो image बन रहा है ना, that is real and inverted and falls in the retina. And once it falls in the retina, it provides the signals to the brain, and accordingly brain activates. और जब तक वो brain के पास जाएगा, तब तक जो image है वो क्या हो जाता है straight. The image is in nothing but it forms in the straight part. Okay, now please understand this defects of the vision.
Defects of vision and their corrections.
Yes. So many
Some
we
people cannot
see
things clearly.
हाँ. So majority ना many of you like you all are kids now, so hardly matters. But as you grow, you can find one defective thing in your eye that कुछ दूर की चीजें नहीं दिखती. Like if you are sitting on the last bench, you are not able to see the board. Or if you are seeing कुछ लोगों को ये प्रॉब्लम होता है कि दूर का नहीं दिखता, और कुछ लोगों को ये प्रॉब्लम है कि नजदीक का नियर का they can't see. And there are some person who can't see both the things. Okay, so कौन से defects है vision में, and what are the corrections, like how to correct this if I'm not able to see a thing at a far distance. far मतलब बहुत दूर है, एक normal thing जो मुझे दिख रहा है but you can't see, so that is a thing which is to be concerned. वो concern का part है, so that is called as a defect of the vision. So there are different defects of the vision, and accordingly the corrections can be also done. Okay, let's understand. चलो pay attention.
Due to loss of accommodation power of their lenses in their eyes.
So some people cannot see things clearly. See, some people cannot see clearly. And what is the reason? Due to the loss of accommodation power of the lenses in their eye. तो उनके जो power of lens है, उसका accommodation is not correct. That is why they are not able to see this. See, can you see the blur part of the boat? Yes, this is how the people see. The far अगर नहीं दिख रहा है ना, this is how it will look. Pay attention.
Because of defective refraction by the lenses, their vision becomes faint and fuzzy.
See, actually, ये जो lens है, what it does, it adjusts accordingly so that कि वहाँ पे ये जो retina है ना, ये retina पे the thing should fall properly on this retina. But can you see after converging the rays, it is not forming exactly on retina. वो retina के ऊपर form नहीं हो रहा है. Rather वो थोड़ा सा प्रायर, थोड़ा सा पहले वो फॉर्म हो रहा है. तो दिस तो उसके वजह से थोड़ा सा फजी ब्लर जो बोलते हैं ना हम, थोड़ा सा फेंट ब्लर वैसे काइंड ऑफ इमेजेस फॉर्म होते हैं. ओके, यस प्लीज पे अटेंशन.
There are three types of refraction defects. 1. Nearsightedness or myopia.
Yes, so we have nearsightedness or myopia. Depending on all these things, we have to understand the first defect of vision. The first vision, it is called as a nearsightedness or myopia. Now see, can you see the name nearsightedness? So by understanding the name itself, you will understand what exactly it is. Okay?
In this case, the eye can see nearby objects clearly, but the distant objects appear indistinct.
Yes. So nearsightedness, in this case, the eye can see nearby objects clearly. तो जो नजदीक की चीजें है ना, you are able to see it clearly, but the objects that are at a very far distance, you are not able to see that things. Okay. So in this case, the eyes can see nearby objects clearly. Nearsightedness, near objects can clearly. Watch, you can see clearly, but ये जो logo है, for example, it is very far, not very far, but at specific distance, so you are not able to see this. Okay, so this is called as a nearsightedness. Chalo, next one.
This means that the far point of the eye is
Very good, Satish. Exactly. This point is very important, extremely important as we are talking about a human eye. You should know exactly the working of the human eye and everything. So yes, it is very important. Okay. Now pay attention.
Is
Good
not
one. Your
at
project
infinity,
topic is good.
but shifts closer to the eye.
Now see, as we say that nearsightedness दूर का नहीं दिख रहा है. क्यों? क्योंकि the image जो converge होने के बाद ये जो retina पे fall होना चाहिए था, it is not falling on that retina. It is rather forming just before it. So how to solve this? Let's see.
In nearsightedness, the image of a distant object forms in front of the retina. There are two reasons for this defect. One, the curvature of the cornea and the eye lens increases. The muscles near the lens cannot relax so that the converging power of the lens remains large. 2. The eyeball elongates so that the distance between the lens and the retina increases.
Yes, so first is because of the lens and the because of the lens, and the second thing is कि ये जो eyeball है that has got increased. Fine, this eye has got elongated. So इसकी वजह से यहाँ पे form तो ठीक हो रहा है, just कि ये जो retina है वो पीछे चला गया है. Okay, so this two can be the cases. Now let's see what exactly is the
This defect
answer.
can be corrected by using spectacles with concave lens of proper focal length. This lens diverges the incident rays, and these diverged rays can be converged by the lens in the eye to form the image on the retina.
Exactly. So जैसे first we can see ना ये जो image था it was forming something prior to it. ठीक है, थोड़ा पहले बन रहा था. But now what we have to do? We have to wear the glasses. We have to wear the like normal glasses. तो जब you are wearing the glasses, what happens is first this concave glass will diverge it and afterward तो वो lens से वो converge ही करने वाला है. But जो already converge हो गया था उसको और पीछे ला रहा था. That is the reason the whatever rays are coming, this lens, the work of this lens is to diverge the things and then it will again focus it such that it will form exactly on the retina. Understood? Yes, please pay attention.
The focal length of concave lens is negative, so a lens with negative power is required for correcting nearsightedness.
Yes. So focal length of the concave lens is negative, so lens with a negative power. Okay. So which lens is used for correcting the nearsightedness or myopia? You are using the concave lenses. So concave lens is negative. See, the focal length is negative, and hence the problem can be solved. Now let's understand the next thing.
2.
Farsightedness.
Farsightedness or hypermetropia. In this defect, the human eye can see distant objects clearly but cannot see nearby objects distinctly.
Now you will think that this is very
means that
different.
the near
Okay.
point of the eye
हाँ, तो you will think that this point is different, but exactly things happen कि जो दूर का है you can see it easily, but जो near है ना you can't see it. For example, your watch, your wristwatch you can't see it, your mobile phone you will not see it. So जो चीज़ें near है it is not able to see, और जो चीज़ दूर है you're definitely able to see. So this type of things are called as the farsightedness or hypermetropia. Okay, yes, चलो let's understand this thing.
eye is no longer at 25 centimeters but shifts farther away. The image
Yes, myopia happens in normal eye. We have seen ना दो cases है. First is कि ये जो हमारा eye है वो elongate हो जाता है, या second the things which are responsible for focusing things is the lens inside our eye. वो lens की वजह से भी हो सकता है. So these are the two things because of which the myopia या hypermetropia occurs. Okay, now let's understand this.
images of nearby objects get formed behind the retina.
Yes, previously this image was forming ahead of retina, and now in this the image is forming behind the retina. Okay, okay, pay attention.
There are two reasons for farsightedness. 1. Curvature of the cornea of the eye lens decreases so that the converging power of the lens becomes less.
Yes. So now, as I told you, now who was asking me? Myopia happens in normal eye. Yes, yes, myopia happens in normal eye because of this lens and cornea. Okay, this is the first thing, and second is the elongation of the eye. Okay.
2. Due to the flattening of the eyeball, the distance between the lens and retina decreases. This
Yes. Now, two things. First is as myopia में it was like the elongation of the eyeball. यहाँ पे hypermetropia में it is the contraction and the flattening of the eyeball. Okay. So this defect can be corrected by using the convex lenses with the proper focal length.
defect can be corrected by using a convex lens with proper focal length. This lens converges the incident rays before they reach the lens. The lens then
So there we were using basically the concave lens for diverging and then focusing, but here what we are doing is we are already diverging it so that आगे जाके क्या होगा और थोड़ा सा properly diverge होगा. Okay, let's understand.
converges them to form the image on the retina. The focal length of a convex lens is positive, thus the spectacles used to correct farsightedness has positive power.
In the myopia we were having the negative power, and in this we are having the positive one.
The power of these lenses is different depending on the extent of farsightedness.
Now see, अब जब आप दूसरों का अगर if you are using the spectacles or something like that, it won't work because everyone is having a different power of accommodation of the eye. तो हर एक का जो power है that is different for everyone. That is the reason where when you use किसी दूसरे person का spectacles ना, it will not work for you. Okay, so as you can see here, different spectacles are having different power. Some are with positive, some are with negative, and everything. Okay. Okay, let's understand. Now let's understand the third one.
3. Presbyopia.
Presbyopia.
Generally, the focusing power of the eye lens decreases with age.
Now this is because of the age. Okay, so the focusing power of the eye lenses decreases with the age. So the muscles near the lens lose.
The lens lose their ability to change the focal length of the lens.
Now this is not because of the elongation or flattening of the eye. This is basically because of the age. Okay.
The point of the lens shifts farther from the eye. Because of this, old people cannot see nearby objects clearly. Sometimes people suffer from nearsightedness as well as farsightedness.
So many a times people have both the issues, nearsightedness भी और farsightedness भी, कि नजदीक का भी नहीं दिख रहा और far distance का भी नहीं दिख रहा. उस time पे what kind of the things we have to do? Pay attention.
Bifocal lenses are required to correct the defect. In such lenses, the upper part is concave lens and corrects nearsightedness, while the lower part is convex lens which corrects the farsightedness.
Yes, so in that case, we have to treat this myopia and hypermetropia, both the things, nearsightedness, farsightedness, दोनों का we have to take care. So we can't use two specs, no? So in the same glass, we have to use two different partitions of the lenses are being used. The upper one is the thick one, that is the concave, and the lower one is the thin one, that is the convex. So both the things has been corrected by using a single spectacle. So the upper part is a concave lens which treats the nearsightedness, and the lower is a convex which treats the farsightedness.
Try this.
Yes, let's understand this thing.
Apparent size of an object. Consider two objects, PQ and P1Q1, having same size but kept at different distances from an eye as shown in figure, as the angle alpha subtended by PQ at the eye is larger than the angle beta subtended by P1 Q1,
Yes, जो
PQ
नजदीक
appears
होता है
bigger
basically,
than P1
जो नजदीक होता है that you will find the larger angle, and the one to which you are seeing at a very far distance you will find a smaller angle. Okay, हाँ, pay attention.
Q1. Thus, the apparent size of an object depends on the angle subtended by the object at the eye. Use your brain power.
Okay, now let's understand this. Uses of the concave
Use of concave
lenses.
lenses. A. Medical equipments, scanner, CD player. These instruments use laser light. For proper working of these equipments, concave lenses are used.
Yes, now this is just an example. What are the
The
uses of
peephole
the
in door.
concave lenses? So just understand things, okay? Yes, the second one is the peephole in the door. Like this is very familiar to us, okay?
This is a small safety device which helps us see a large area outside the door. This uses one or more concave lenses.
See, this is very interesting to understand. They're using one or more concave lenses, okay?
P. Spectacles. Concave lenses are used in spectacles to correct nearsightedness. D. Torch. Concave lens is used to spread widely the light produced by a small bulb inside a torch.
Correct.
E. Camera, telescope and microscope. These instruments mainly use convex lenses. To get good quality image, a concave lens is used in front of the eyepiece or inside it.
Yes, so this all are the examples of the concave lens. Basically, any of the parallel coming rays, we have to diverge it, we have to spread it. At that time, we are using the concave lenses. So basically, torch. Okay, so अगर I'm using a torch. अगर मैं torch का अगर light को कर रही हूँ, तो I want to focus a large distance, right? तो मुझे light I want to spread the light to a large distance. So all the lights are coming in the parallel way, and then with the help of the concave lens, it is spreading to it is covering a very large distance. So at that time, we are using the concave lens. Second is a peephole. Peephole के लिए भी also we know just by looking into a specific distance, I want to see the maximum area covered. So diverging. So all the things are diverging. Also, you have different things: the camera, the telescope, the microscope, and everything. Understood? Now let's understand the uses of the convex lenses.
Use of convex lenses. A. Simple microscope. A convex lens with small focal length produces a virtual, erect and bigger image of an object as shown in the figure.
So the simple
Such a
microscope
lens is called simple microscope or magnifying lens.
lenses. The magnifying lens is
One
also an
can get a
example
20
of that.
times larger image of an object using such microscopes.
Yes.
These
So
are
see,
used for watch repair.
so focusing or focus अगर कोई भी छोटे से छोटे part पे if you want to focus, at that time we use the convex lenses. Sorry. So what are the examples? See, watch repairs, testing precious gems, and finding their defects.
Testing precious gems and finding their defects. B. Compound microscope. Simple microscope is used to observe small-sized objects. But minute objects like blood cells, cells of plants and animals, and minute living beings like bacteria cannot be magnified sufficiently by simple microscope. Compound microscopes are used to study these objects.
Yes, so just by using a magnifying glass or a simple microscope, it is not at all possible for you to understand the bacteria because the size of the bacteria is very small. ठीक है, तो बहुत ज़्यादा small bacteria होता है, right? तो उस time पे a single microscope can't work. Simple one. So basically, we have to use the compound microscope for understanding, for studying or for viewing this kind of objects.
A compound microscope is made of two convex
Correct,
lenses,
Satish.
objective and eyepiece. The objective has smaller cross-section and smaller focal length. The eyepiece has bigger cross-section. Its focal length is also
As it
larger
is
than
compound,
that of
so
the
two
objective.
lenses.
Higher magnification can be obtained by the combined effect of the two lenses. The magnification occurs in two stages. The image formed by the first lens acts as the object for the second lens. The axes of both lenses are along the same line. The lenses are fitted inside a metallic tube in such a way that the distance between can be changed.
Yes, so understand this as we are using the compound microscope. So as we say compound microscope, they have the two lenses, compound, single, simple means single, and in the compound we have two. The first is called as the objective lens and next is the eyepiece. Now see, as I have kept the object here, see, can you see the object kept
Higher
here? So
magnification
as
can
the
be obtained
object,
by the combined effect
understand?
of the two lenses. The magnification occurs in two stages.
So object is
of
kept
both
here. See, object is kept here. तो ये first वाला lens जो है वो work करेगा and accordingly image is formed here. Now for this IP, this image formed by the first one act as the object. तो ये अभी ये वाला object को refer नहीं करेगा. This will refer to this one and accordingly image will be formed. Okay,
Lenses are
I
along
hope
the
everything
same
is
line.
understood by everyone.
The lenses are fitted inside a metallic tube in such a way that the distance between can be changed.
Yes, now let's move on to the next one, that is the optical instrument.
Optical instrument. Convex lenses are used in various other optical instruments like camera, projector, spectrograph, etc.
These are just the examples, okay?
Spectacles. Convex lenses are used in spectacles for correcting farsightedness. C. Telescope. Telescope is used to see distant objects clearly in their magnified form. The telescopes used to observe astronomical sources like the stars and the planets are called astronomical telescopes.
Yes, as we all know that if we want to study about different planets and everything, that we are using the telescope, and that particular telescope is called as the astronomical telescope, okay?
One, refracting telescope. This uses lenses. 2. Reflecting telescope. This uses mirrors and also lenses.
So with the mirror it will reflect.
The image formed by the objective acts as object for the eyepiece, which forms the final image. Objective lens has large diameter and larger focal length, because of which maximum amount of light coming from the distant object can be collected. On the other hand, the size of the eyepiece is smaller and its focal length is also less. Both the lenses are fitted inside a metallic tube in such a way that the distance between them can be changed. The principal axes of both the lenses are along the same straight line. Generally, using the same objective but different eyepieces, different magnification can be obtained.
Correct. Now let's understand this.
Persistence of vision.
Persistence of vision, which is important.
The eye lens creates its image on the retina. The image is on the retina as long as the object is in front of us. The image disappears as soon as the object is taken away. However, this is not instantaneous and the image remains imprinted on our retina for 1/16th of a second after the object is removed.
Yes. So now you all tell me, अगर वहाँ पे object ही नहीं है, तो is it possible for you to obtain an image? अगर mirror के सामने object है, तब तक आपको image दिखेगा. The moment you remove the object, will the image be the same? No, it is not possible. Similarly, if you have something in front of you, ठीक है? तभी क्योंकि now in front of me, I can see the like all the setup and everything, and you can see the screen and everything. तो जब तक है, you will understand the thing. But the moment it will stop, also the image formed on the retina will also stop. But it is not that it is very instantaneous. Spontaneously or फटक से stop नहीं होगा. Yes, the persistence of the vision stays there for 1/16th part of the second. Okay. Yes, the sensation of the retina persists while
persists for a while. This is called persistence of vision. What examples in day-to-day life can you think about this? Can you tell?
Okay, so see, this is how the persistence of the object was
Persistence of
working.
vision.
Okay, so
You
I
see
hope
an
everybody
object
understood this because it is using 1/16th of the second after the object has been removed. Okay, and due to this, the persistence of the object, and that is the reason why in day-to-day life we understand that even though if something is removed in front of your eye, the thing is kept in your mind as it is. Okay, fine. Okay, so I hope the lenses part is clear to each and everyone. Okay, so let's stop the class here as time is up and also the chapter has been completed. See you all in the next lecture. I hope everybody understood chapter number 7, lenses.